Alan Turing, best known for his work behind World War II, accomplished many other feats that inventors of the past would only dream of. Born in April 1912, he attained many momentous achievements throughout his life. One of the most important things he achieved was working with the British government to decrypt Nazi codes. These were referred to as the Enigma.
Prior to World War II, Polish cryptanalysts were able to develop a machine that was able to decrypt the Enigma. This machine, named the Bomba, used basic deciphering techniques to decrypt the code. It was a basic system, but it still helped provide pivotal pre-war information. The Bomba faced a significant obstacle when the Germans discovered their code was being decrypted. They eventually altered their operating procedures, causing the machine to become ineffective.
This is where Turing comes into play. Along with the help of mathematician Gordon Welchman and the British government, he was able to develop a machine similar to the Bomba that cracked codes faster and more efficiently. Alan Turing's crew in Bletchley Park was able to create one of the first functional computers ever.
Fast forward to about 5 years later, Alan Turing has victoriously cracked the Enigma and saved many people. World War II is over, and he has published a paper about whether machines can think as humans can. He titled the paper, Computing Machinery and Intelligence. In his paper, he referred to machines' ability to think as the imitation game, which is later called the Turing test. The Turing test is somewhat simple to understand, yet extraordinarily difficult to pass.
In order for a machine to pass, it must have a successful conversation with a human. But there was a catch. For the machine to have the said successful conversation with the human, it could not be detected. So far, this test has not been passed, proving Turing's theory wrong. He stated that by the year 2000, a computer would be able to play the imitation game so well that an average interrogator would not have more than a 70% chance of making the right identification after 5 minutes of questioning.
Alan Turing was a British mathematician who became one of the world's first computer scientists. His research led to the groundbreaking experiment known as the Turing test. Created in 1950, it was meant to prove a computer's capability to learn. The Turing test stands as a turning point and inspiration in technological history, leading to the exploration and creation of artificial intelligence technologies that shape our future.
Our focus revolves around turning points in history, highlighting how the absence of computers places us in an era of societal underdevelopment. Technology has not only opened numerous avenues for individuals, but has also presented challenges. The imitation game stands as a prime pathway for ingenious minds to navigate obstacles.
The Turing test serves as just one instance showcasing the impact that computers have had on our lives, illustrating a cause and effect relationship. Something major to take into consideration is that the amount of technological development that has come from ideas based on the Turing test is astronomical. AI is a major idea that came from the Turing test. Many computer scientists and developers have focused on making more sophisticated AI to help better the lives of people. It means that humans no longer have control over what computers do, since they now have a mind of their own.
The scale of impact that computers have on us extends beyond just the domain of artificial intelligence. Computers have become integral to the fields of medicine, finance, transportation, and many more. This is important because the amount that we rely on them may force us into a world where we cannot evolve with them. We need to be careful not to give too much power to computers, otherwise we might become inferior to AI. If they become stronger than us, we may not be able to thrive any longer. In 1966, the first notable attempt at passing the Turing test was Joseph Weizenbaum's program ELIZA. It is referred to as a chatbot or one of the first virtual assistants. ELIZA was a groundbreaking machine that simulated a conversation between a user and a therapist. The program used simple patterns that matched prompts with scripted responses to engage users in a conversation, often repeating questions or statements to simulate a therapist's style of dialogue.
The Turing test inspired this by creating a goal that Weizenbaum was trying to accomplish. Even though ELIZA was one of the first attempts, it didn't come close at all like some more recent computer programs. Since computer programmers like Weizenbaum had no idea what they were getting into, he gave ELIZA other purposes as well. ELIZA's most famous script was Doctor, where it posed as a therapist and helped change the lives of some people with psychological issues. The idea of scripted answers is one major flaw in ELIZA's structure and is the dominant reason it didn't succeed in passing the test. Turing's theoretical work laid the foundation for the idea that machines could engage in human-like conversation. ELIZA was one of the earliest attempts to create a computer program capable of making this theoretical work fact.
This attempt was directly influenced by the Turing test, and that is proven solely by it being tested as a Turing test function. Back when ELIZA was created, the Turing test was in its beginning stages, and ELIZA was the first of many programs to come.
Perry, a 1972 program designed by Kenneth Colby, took place about 6 years after the creation of ELIZA. It was written to be ELIZA's patient, as ELIZA was a psychotherapist chatbot. Even though Perry's main purpose wasn't to pass the Turing test, the test still contributed to its birth.
Perry was meant to simulate a person with paranoid schizophrenia. It was built off of concepts and beliefs, even if they were somewhat stereotypical. The use of stereotypes is not abnormal for its time, but it still shows us how stereotypes affect history.
The main reason for ELIZA's creation was to pass the Turing test by posing as a human psychotherapist. If the test didn't exist, the probability that ELIZA would exist is almost zero. Given that Perry was written majorly because of ELIZA, Perry wouldn't exist either.
This is a demonstration of how Alan Turing affected many computer scientists. Even though the main purpose of Perry wasn't to pass the test, it was an assistant to a program that was meant to. Many machines and programs we have now are most likely directly or indirectly influenced by the Turing test. Eugene Goosman was the latest notable endeavor at passing the Turing test. Developed in 2014 by software engineer Vladimir Veslov, it was programmed to act as a 13-year-old Ukrainian boy. The date Eugene Goosman was tested was also the date that marked the 60th anniversary of Alan Turing's death.
Subsequent to being interrogated by the judges, Eugene managed to deceive 33%, or 10 of them, into thinking he was human. But technically, he did not pass the test. In order to pass the test, a program needs to fool at least 95% of the judges in 5 minutes.
This was not the case. Some argue that Eugene did pass the Turing test, since the program managed to fool the highest number of judges ever recorded. The 65-year-old iconic Turing test was passed for the very first time by computer program Eugene Goosman during Turing Test 2014, held at the renowned Royal Society in London on Saturday. This quote helps prove our thesis by showing that Eugene's sole purpose was to pass the Turing test. It shows this by describing how it was first tested at the Turing test competition.
This is major because it demonstrates how Alan Turing inspired Vladimir Veslov and company to create an amazing piece of computer software. Another thing that this quote explains is proving how some people believe Eugene passed the Turing test. The Chinese room argument is an article that was written by John Searle, an American philosopher in the 1980s. It stated that a computer program would not be able to comprehend Chinese because the computer may appear to understand it, but not produce a real understanding.
Searle's logic behind this test starts with him imagining himself alone in a room. A computer program follows, and it responds to the Chinese characters slipped under the door by Searle. He copies the program for manipulating symbols and numerals just as a computer does, sending the appropriate string of characters under the door. It leads to those outside to mistakenly suppose there is a Chinese speaker in the room.
Since the argument is hypothetical, it is obviously flawed. This is because it hasn't actually been tested yet. One of the most major defects is that the argument assumes that understanding language requires more than just manipulating symbols.
This hypothetical experiment was directly influenced by the Turing test. John Searle's main focus was to try and find loopholes in the test and why it was impossible to pass. Admittedly, both theories, Turing and Searle's, have many imperfections and insufficiencies, but people today are still building off their work to make it more stable and accurate.
So, after all this talk about mathematicians, scientists, and computer programmers trying to pass the Turing test, how about you ask yourself what would happen if there was a success? Would the world end as we know it, taken over by computers, or would we live in a world with major technology advances for the better? This is a question that we are still trying to find the answer to.
The successful passing of the Turing test would represent a pivotal moment in the development of artificial intelligence. It wouldn't end the world as we know it, but this achievement would open the door to a future denoted by remarkable technological advancements. AI has been developing for over half a century, and Alan Turing is to thank for it. His ideologies of what a computer is capable of has inspired many scientists, such as Dr. Weizenbaum or Dr. Veselov, to create life-changing programs. but these are still the beginning of many more to come.